Hi guys, today we'll dive into the fundamental concepts of DAX for Power BI. Whether you're a beginner or just need a refresher, this guide is for you. In this tutorial, I'll be covering where DAX can be used inside Power BI, DAX building blocks, calculated columns versus measures, DAX main functions, and raw context versus filter context, and finally calculate function. To make the best of this tutorial, try to follow on with this tutorial, pause when necessary to do the work, and make sure before you start to download the source data and the Power BI file covered in this tutorial. You'll find it in a link in the description. Now grab a cup of coffee and get ready to learn DAX. DAX is short for Data Analysis Expression. It's a formula code specifically used for data analysis for Power BI, analysis services, and Power Pivot in Excel. For this tutorial, we'll use sales data for some products. We have those two tables. Let's see the available columns. So we have, first of all, product table contains the different products and an ID for each of those products. And then we have some sales data. We have the date, the product, where it's sold, the location, the number of units sold, and the unit price. If we go to the model view, we can see that the products table and the sales data are connected through the product name. So where can we use DAX in Power BI? There are three ways to use DAX in Power BI. The first one is to create a new table, calculated table. The second one is creating a measure. And the third is creating calculated column. To create a table, you can do it from here. You go to modeling and create a new table. You can see the formula bar open for us where you can feed in the DAX code. The second way is creating a measure, and you can either go from calculations in modeling, you select a new measure and you feed in the formula here, or you can simply go to one of those tables and right click and select a new measure. The third way is through a calculated column, and you can do this again from modeling and select a new column. Here you can add the formula, or again by right click on one of the tables you can find the option to create a new column. Before we try to use any of those options, let's try to understand the building blocks of the DAX code. The first building component in DAX is a predefined formulas that are called functions, like for example sum or average or count. So for example, let's go to the sales data here. Let's try to create a new measure. Right click, new measure. Let's call it average price. Equals, we'll use the predefined function called average. You just type average and you can see here it gives you the options. I'll just use this function. It automatically shows the different fields. Let's select unit price, close the bracket and hit enter. So now we have a measure that shows the average of the unit price based on the DAX formula. And to see the value of this measure, we can simply, for example, use a card and feed the average price to it. We can see that this is the unit average price. The second building block is operators, and we have many types of operators. For example, the arithmetic operators like plus, minus, multiplication, or division. For example, let's create one calculated column to show the total price based on the unit price and the units sold. So we go to the sales table, right click, new column, we type total sales equals, we just type unit price, you can find it here, and we use times units sold. Hit enter. So now we can see a calculated column created here. It shows here this icon. So if we use a table and we feed to it, for example, the product and unit price, units sold, and total sales. Let's expand this. So we can see that if we multiply the unit price in this table by the units sold, we will not get the total sales showing here. And this is because this table shows the sum across multiple dates and multiple locations. However, if we go to the table view, we can see that a new column created, and it applies at each row, multiplying the units sold and the unit price to get the total at the row level. This concept, we'll get back to it later in this tutorial. The other type of operators is comparison operators. And these operators include equal to, not equal to, greater than, less than, greater than or equal to, less than, and equal to. For example, if you want to create a new table based on the sales data that contains only the unit price bigger than 200, for example, you can simply go to Modeling, New Table. Let's name it Products Above 200, equals, Filter, Sales Data. So we select the whole table and use the comma, and we select the field unit price, and we just use the operator bigger than 200. Hit enter. We can see here a new calculated table created. It has this icon signifying that this is a calculated table. So if we go to this table from table view, we can see a new table created with all the fields where unit price starts from 200. Now if we go to the main table, we can see we have unit price starting from 56. So we have a new table filtered based on the operator. The third type of operators, logic operators. And for logic operators, we have and, or, and not. For example, if we want to create a new table that shows laptops sold in Dallas, you can simply again go to Modeling, go for a new table. Let's name it Laptops in Dallas, equals, again, use Filter, Sales Data, and we filter for product equals laptop, and we use and logic, location, we select the location field equals to Dallas, and we close the brackets and hit enter. We can see again a new table was created. Let's see from table view. So we can see a new table created where the location is Dallas and the product is laptop. So these are the different operators we have. And the final building block, we have constants. You can create a numeric number, a text, or binary like true and false. So for example, let's add a calculated column with a constant value to the product table, a new column. We name it type, and we simply give it the value electronics. Hit enter. So now if we go to the table view, we can see for the products, we have a new column created called type, and it has the value electronics everywhere. At the beginning of this tutorial, we mentioned that there is 3 ways you can use DAX inside Power BI, and we saw how to create tables, calculated columns and measure. While creating a new table is clear, it's important to understand the difference between calculated column and a measure. So what is a calculated column? Calculated column is adding a new data to an existing table. For example, for the sales data table, we added a new calculated column named total sales before. And we saw that in the table view, a new column was added, and it's static and always there, and it is applied on each row of the table. It's equivalent to create a formula in an Excel sheet. For example, you just multiply two values from two different cells to get a new value in a new cell. So this is static, it doesn't change, and it's always there. It is stored in your data. However, for measures, if you remember, we added the average price as a measure. We can't see it in the table. There is no new data stored here. So this is a dynamic calculation applied on a data based on the filters or the contents of your report. To understand this better, let's go back to the report view, and here we have the average price measure we created earlier. So this right now it's not filtered, and it's showing the average price for all the products within our sales data table. But let's apply some filters to this visual to see how it works. I'll just select this visual, and from the filters here I will add, for example, from the same table, the location. So if I apply filter only for Chicago, for example, we can see that we have the average price sold in Chicago only. So measures are a dynamic way of creating functions without storing the values, and it responds to filters and slicers in your report. So even if we try to add the measure to this table, for example, let's select this table and add the average price as a new column. We can see it aggregates for each of the products. So we have the camera, we have the average price in that table, and the charger, and so on. So measures are a dynamic way to store aggregation or calculations, and gives you the freedom to call these calculations without storing the actual data in your table. And also measures allows you to do some advanced calculations or more complicated calculations. It's out of the scope of this tutorial for now, but it will give you a way to manipulate the data that calculated columns or data transformation will not allow you to do easily. We briefly covered functions, but let's look now at the main functions available in DAX. We have the core functions, which are sum, we have the average, we have the count, we have minimum and maximum. Let's, for example, look at max function. So if we go to the sales data table and create a new measure to show the maximum unit price, let's name it max price, and we simply type max. And there's one important thing to notice here about DAX. DAX is case insensitive, so it doesn't matter if you're using uppercase or lowercase, you will get the same value. Let's keep it, for example, here lowercase, and look for unit price field from the sales data table. Close the brackets, hit enter. We can see a new measure created for us. Let's feed it to a card here. We can see now we have the maximum price. So these are the core functions available in DAX. The other important set of functions you will always use in Power BI is date intelligence functions. And for that we have total year to date, total quarter to date, total month to date, and add date, and others. Let's, for example, see how to use total year to date. Let's, for example, look at this table here. Let's bring it at the top first, expand it a little bit. Let's filter it for one product. For example, let's look at cameras. So now we have it filtered for cameras. Let's add the date to this table. So the date of sales, let's put it here. Let's keep it as full date without hierarchy, so we can see the dates of sales. Let's have it as ascending order, starting from the earliest date. Now, what we want to do, we have the total sales for each of these dates. We want to create another measure that shows the total sales from the start of the year till the selected date. And we have everything as 2021 here, as you can see. So let's, for example, try to have the cumulative sales based on the date. To do this, we'll create a new measure. From the sales data table, right click, select new measure. Let's name it year to date sales or YTD sales, and we'll use total YTD function. Here we have the function, we can just select it. We'll add the expression, so we want the summation of the total sales, so we'll use the summation function. So now we're combining two functions, and we'll type total, and we can see from the sales data we have the total sales. Let's select it. So now we're trying to sum the total sales since the start of the year. Next, we want to add the dates we are going to use, and for that we'll use the same date field from the sales data table. You can see it here, and just close the bracket. Hit enter. We have the measure created here. Let's just simply add it to the table. So what does this do? It calculates the totals from the beginning of the year. So we have here from the beginning of the year 44,000 is showing here. The next row, it shows the combination of those two or the summation of those two. The next one showing the summation of those three, and so on. So it keeps adding total till a new year begins. And since here everything is 2021, it will keep summing all of them. And we can see here we have the total as of the last row is equivalent to the total sales. So now you can see the importance of date intelligence function within DAX in Power BI. Let's look now to another type of functions, filter functions. And before, we have created a couple of tables using those functions. So we created the products above 200 function, and you can see here we use the filter. This function allows you to filter a whole table based on certain criteria. And we have other type of filter functions, for example, all and related. Let's, for example, see how we can use related function. Earlier we saw from the table view that we have the sales data table. It contains the products column, and we have also a product table that contains the product and the ID of that product. And if you remember from the model view, we said that those two tables are linked using the product name. Let's say I want to bring the ID column here to our sales data table. So we can see here we don't have a field called the ID. So let's try to create a calculated column that will show the ID here. And this is where the related function comes handy. So let's right click on the table and select a new column. Let's name it product ID equals related. You can see the function here, hit enter. And from products, let's select the product ID. Close the brackets, hit enter. We can see how now the product ID is added, and it automatically matches the product ID to the product name across all the table. There is one important concept you need to understand while using functions in DAX within Power BI, which is the difference between raw context and filter context. And the best way to explain this is to see it in an example. Let's create another page. And for example here, we're going to add a new table and again feed to it product and the total sales. So if you see here, we have the summation of the total sales automatically calculated based on the calculated column we created earlier. So this column multiplies the unit price and the units sold at each row. So if we go to the table view, we can see the total sales is calculated at each of the rows, and the summation of this column will give us the total sales. So if we want to create a measure to give us this total without creating a calculated column, we need to use SumX function. How does it work? Let's go to the sales table, right click and select a new measure, and let's name it overall sales equals. We're going to use a function named SumX. So this is the function, and here the first variable we need to provide the data set we're looking at or the table, and for that we'll use the sales data and then feed in the expression. The expression will be unit price times units sold. Close the bracket and hit enter. So notice here we didn't use the calculated column we created for the total sales here. We tried to calculate it immediately by multiplying the unit price by the units sold, and it needs to be done at row by row, then sum all of them. Let's put this measure in a card. So this is the measure overall sales, and you can see here the number is equivalent to this number, but here it's rounded because it added million, but we can remove the units from the card. Let's show none. So we can see here the total number is exactly equal to this. Now to understand the difference, let's try to use the normal function. Let's again try to create a new measure. Let's name it overall sales 2 equals, we'll use the normal summation, just the sum, and we can notice that this function accepts only one field, which is the column name. So let's use the unit price from the sales data table, then multiply it by, again, sum units sold. So we have from the sales data table here units sold. Let's close the bracket, hit enter. So we have the new measure created. Let's copy this card and replace the field with the new measure. You can see that we got a huge number, and obviously this is not the correct number. The reason why, if we go to the table view, what this measure does, it sums first all the units sold and sums up the unit price, all of them, then multiply them by each other. So it doesn't do it in row by row basis. So this is a very important concept you need to remember when you're using DAX. Let's now look at the most powerful function in DAX, which is the calculate function. I don't remember I created any Power BI dashboard without using this function. It becomes very useful, especially when you're trying to create measures. It allows you to manipulate and aggregate the data in a very efficient and easy way. Let's look to an example how to use the calculate to understand the importance of this function. Let's start by creating a new page and add a new table. For this table, we're going to have only the date, and we'll keep only the month. So let's remove the day, year, and quarter. So we have the month here, and let's add also the total sales. So what we have here, we have the total sales month by month for each month of the year. Let's just expand it to see December. So we have all the months here. Now, suppose you want to create another column to this table that shows the sales from the previous month. For example, for February, you want here to see January sales, and so on. To do this, we're going to create a measure utilizing the calculate function. Let's go to the sales data table, right click, new measure, name it sales previous month or PV, and here we're going to use the calculate function. This calculate function allows you to get an expression and filter it. We'll use the sum function and select the column total sales from the sales data table, and we close the bracket, comma, then we apply a date filter. Let's use date add, and we select the date field from the sales data table, comma, the interval will be -1. We want to go back 1 month, again, comma, and here it allows you to select the interval, whether it's day, month, quarter, or year. We'll select month. Let's close the first bracket and the calculate bracket. Hit enter. So now we have this measure. It's supposed to give us the previous month sales. Let's feed it in to the table. Once we feed it into the table, you can see that we didn't get any value. And the reason why, because you're trying to look at the total sales for the previous month, for each of the rows here. So for February, for example, you're trying to look at the sales of January. And remember, measures are dynamic and respond to filters. And because we have only here this row filtered for February, when you're trying to show a value for January, it will be filtered out and it shows blank or no value. So how to overcome this? All we need to do is to make the calculate function ignore the date filter. How to do this? We simply add another filter. You remember one of the filter functions we saw is all. So simply all to remove filters from a table or a column. So we just need to select the sales data table. Let's hit commit or enter. And we can see now the previous month sales are showing as expected. So this is the power calculate function gives you. It allows you to manipulate the data in many ways and play with filters.
I hope you found this introduction to DAX useful. Guys, DAX is a must to master if you're serious about learning Power BI. It enables you to create deep insights that standard functions within Power BI cannot achieve. Its versatility transforms raw data into meaningful matrices, transforms your Power BI dashboards and reports to a professional analytical tools. Remember, practice makes perfect. Visit the advanced projects we covered in this channel before and see how we used DAX to create stunning Power BI dashboards and reports. Feel free to drop your questions in the comments below. If you're new, make sure to subscribe to this channel to stay updated with future tutorials and advanced data analysis projects.